Hi guys, so I thought I'd start a tutorial series of things that I couldn't quite cover in class but would be good to share with you guys. So I'm going to go over a couple of things about math in Grasshopper, and hopefully we can get some more information that you guys can use in some of your assignments. So we'll go ahead and start off by creating a panel with a set of numbers, and these can just be random numbers for this case. Just something I can use, whatever. Okay, I've got a handful of them. They range in number, and they're not in any specific order. 0 to 25 and stuff in the middle as well. So you can see right here, they're just a list of numbers, but I actually want individual numbers, so I kind of want them to show up a little different. So if I click on multi-data, then they actually come in as individual objects. Before they are just read as text. Okay, so I'll start out with that as a set of numbers that I can work with for these exercises. Okay, so from here I can do a couple of things. I can, since they're integers, I can pass them to an integer container. I can get some information about them. I can say the average of all these numbers. You can see that's going to be somewhere like that, 6.8. I can understand a little bit about the list as a whole. Like maybe I want to know what the highest and lowest number are. So I can do something like say what are the bounds of the list. So this will tell me that it goes from 0 to 25. I already knew that because I put the numbers in there, but in some cases I might not know that. And then I can start using them for other operations. So if I wanted to say test for some quality, so in Grasshopper or in general math, there's Boolean operations. And you might be familiar with these with modeling, where you combine objects and things like that. But it's a true-false operation. Either they're something, if a given equation is true, then it would be 1 or true, or something is false, which would be 0. So you can set one of these up by saying testing for something that's smaller than or greater than. So I'm going to say, are all of these numbers, or if any of these numbers are greater than or less or greater than, smaller than 10. So in that case, it will give me a list where this one is associated, this is smaller than, this is smaller than, this is smaller than, not till I get down to 7 and 8 are these no longer smaller than. 10 is equal to, 25 is greater than. So then that gives you a set of true-false statements that you can use. I can also use that information to then separate out those numbers. So if I were to dispatch this list of numbers by these values, it would give me these two lists. One where that was true, so all of these are smaller than, and all of these are not smaller than. And that doesn't necessarily have to work for just numbers. I could do that for shapes and objects. I could say if the volume of a circle is greater than this, then put it in one list, and if it's smaller, put it in another list. So that works with objects as well. I can also there's a set of pretty standard math operations. If you go under math, you'll see operators up here, so you can use addition, multiplication, division, make numbers negative, use power, absolute value, pretty standard things that you should know. Those are all up here. These are your sort of Boolean operations or tests. It tests if it's equal, it tests if it's similar, tests if it's larger than or smaller than. And then we have these things called logic gates, which will sort of take the information you have and then determine whether it is a true or false, or do something to it. So if I were to say use the not gate, in this case I can take all of these, plug them into this, and it would do exactly the opposite. It should say all of these that were true are now false, all of these that were false down here are now true. So you can use this to sort of change the information how you want it. Other ones, you can test if multiple things are true and false. If you didn't know, it's sort of binary. These binary operations are the way your computer works. This is the ones and the zeros that you might have seen or heard of in terms of computer talk. Zeros being false and 1 being true. And so by using these logic gates, you can then build sort of a workflow that the computer can understand. I won't get into that too much, but you can use these things in different ways. So for AND, if you were to use this has now 2 parameters, an A and a B that goes into it. And in this case, it only sends a true if both of these are true. If this and this are true, then this will be true. If one of them is false, then the output will be false as well. Other ones would be OR. So if either of these are true, then this is true. If both of them are false, then this is false. So you can sort of test some of these and see how they work for different applications. Another thing that might be useful is some of these up here that you might not have seen before, maybe Modulus. Could be one that you haven't used before. A modulus is sort of like division, but instead of giving you the answer, it gives you the remainder. And so I can say these numbers modulus 2. And what that'll do is divide each one of those by 2. And you can see here that all the odd numbers give you a 1. All the even numbers give you a 0. So that's almost like a true-false test for odds and evens that you can use. Now, if this number is something else, you'll see that that remainder might go up. So it's not always a binary thing, but you can use it in different ways. Then there are weighted averages that you can use. So you can say the weighted average. Here I can plug in these numbers, this list of numbers. And for the weights, I'm basically assigning a value that I want to say how important each one of these numbers is. So if I have 10 values here, I need 10 numbers. So I'm going to put number slider. Now I'm going to make 10 of these, sort of organize them so we can see them a little better. You see it's going to turn red until I have a value for each one of these numbers. So this system might not be so parametric for situations where that list of numbers is a changing length. Let's see. Should have been right. Okay, so for this, let me see. I can. Oh, there you go. So it wants to accept a. It wants to make sure it's a number, and so these could actually be read as just text, like the text of a 0, a text of a 2-5. So it wants to make sure they're a number. So I can run it through that first. I think I can also maybe run it through an integer if we had that. And so from here, you can see if I make these all the same again. The average, yeah, oh, I didn't quite make it the same. The average should be the same as that one over there. But if I start to weight these to a different amount so that they have different sort of ratios within that, then I can then adjust that. So if I take this last one, or second to last one's associated with 25. So I can turn this one way up. And so even though that's the only number over 10, I can say the average is now 11 because I'm saying this one's more important. Same with the 0. If I were to turn that one way up, I could bring that number down quite a bit. So you can adjust all these to some sort of almost percentage that you're thinking about it. That's really just the ratio between those. You can also do things with maximum and minimum. Get let's see where the maths are. I can say whatever's the maximum number. So if I take this number and I give it another value in here. It'll take whichever one's maximum. So all of these numbers are lower than 10.5, so it's going to replace 10.5 because that's the maximum of the two values that it's considering. The only one that doesn't is 25 because that's actually the maximum when it considers that number to this number. And if I turn that down, you can see that those start to be replaced as they get larger than that number. You can do the same thing with the minimum. Oh. So in this case, 0.9 is lower than all those except for maybe 0, the last one. And I can turn these up until they all sort of reach that number. So one last thing that I want to show in this quick little section is equations. So I can go over here to functions. It's one way of doing it. Where I can also put in an expression. In this case, it's feeding in x and y values. It's running it through a function, either something that I put in here or something that I type in here, and it'll spit out the output. So say I take this average x, and then I say x squared. Let's say x squared in here. So that should give me a value that takes in that x. So the square root of that value. So 6.8 squared, it's going to be this. Now I don't need that y for this one, but I could also say that it's multiple. I could add as many variables as I The same thing for this one. This is just a different way of doing it where I would plug in. I could also say x squared into this one. What a value should give me the same thing. This box gives you a little more freedom to put in other things. You can see the standard one had some format things where you can format numbers to have a different number of decimal places and stuff like that. We won't get into that too much. So let's see, I think that's all I'll go over for this. There are definitely some other things that you can think about. Trigonometric functions, you can use other complex numbers and things like that. We won't get into those sort of things, but if you do need them, you know where they are, where they're available. If you need to deal with matrices, constructing domains, you can use those. Remapping numbers, maybe that's a good one to go over. So remapping numbers, if I have these numbers, but I need them sort of in the same relationship to each other, but need them in different numbers. I can plug these numbers in. I can take this bound, which is 0 to 25, and plug that into that source domain. And maybe I want them all to be from 0 to 1 now, but in that same sort of relationship. So I'll plug this in. You can see that they all get mapped to completely different numbers. What you see here is that the highest number, 25, gets mapped to 1. The lowest number, 0, gets mapped to 0. And the sort of relationship between everything in between gets mapped accordingly. So the 10 is, at 0.4 with respect to the rest of it. 9's close to that, and then everything sort of goes down from there. And so that's a good way of getting sort of normalized values, or if you need them in a slightly different configuration, you can look at that in a different way. I could also say that I could take a graph mapper. So this would actually feed in values and use a graph to determine how they're changed. So I can say maybe a Bezier graph. So just for comparison's sake, I can plug these in here, get all of these numbers. Right now it sort of should look pretty similar because this graph is not changing a whole lot. But I can skew that graph so it sort of warps that scale, so it's not so linear anymore. The top and the bottom should still be the same because this one gets up here and this one comes down here. I guess I could adjust that so that the top doesn't make it all the way up, or change those proportions in some way. So that can be used for a number of things. I'll maybe quickly show an example. Let's draw a quick curve. I think we were maybe dividing curves last time in class. Bring this in. So if I wanted to evaluate this curve, and I had these numbers originally, this might be a scenario where I remap these numbers to something between 0 and 1. Because if I reparameterize that, that means that it's along that from 0 to 1 of the curve. Perhaps I want to somehow distort that in some way, so I can plug that into this one and allow those to shift. And you can see physically how those move around as I change that. They're not changing their relationship, but changing the sort of kind of like the scaling of that along this curve. And so they kind of stay or change uniformly, but with respect to the amount of change this curve is going from that standard slope. You can play around with that and sort of understand how that works a little bit So I think I'll probably stop there. Hopefully this is useful. This is kind of spaghetti right now, but I can clean it up and provide you with more information about this if you so choose.